Welcome to another video series of your oxidation reduction reactions. In this video series, we are going to look at the alkaline method of balancing redox reactions, how you can balance them in an alkaline medium. Of course, between the acidic medium and that of the alkaline medium, the methods are very similar, just some slight differences. For example, when we are balancing in an acidic medium, we said we add water to the side that has less oxygen, but in this case we'll be adding water to the side with more oxygen. And also we said when you want to balance for hydrogen, you are going to add the hydrogen ion. In this case, when we want to balance for hydrogen, we add the hydroxyl ion. These are the small differences. Or if you've mastered the concept of the acidic medium, then there are just 2 or 3 steps you can add to get your final answer in an acidic medium. We will look at a question using that particular method in this particular series. So we look at our first example for this particular medium. Okay, this is the first example that we have, okay? We have the tetraoxochromate 7 that is reacting with the iodide ion in an alkaline medium. This OH minus tells you this in an alkaline medium to produce the chromate ion and the trioxoiodate 5 ion. This is the equation that we are to balance using the concept of alkaline medium. So the first thing we do is we are going to assign oxidation numbers. Oxygen has an oxidation number -2. 4 by this 2 gives us -8. We transpose over, it becomes +8. Plus 8 minus 1 gives us +7. That's what we call this the tetraoxochromate 7. And of course, this is a mono ionic species, so it oxidation number is -1. This is also a mono ionic species, oxidation number +3. Oxygen here is -2. The iodine is +5 because 3 by 2 gives us -6. You transpose, becomes +6. +6 minus 1 is +5. So now you look at these charges and you try to identify which species have oxidized, which one have reduced, and we write out the oxidation half and the reduction half. So here you can observe that the iodide have increased from -1 into +5. So that tells you there is an increase in the charge, and an increase in charge tells you electrons are lost. And when electrons are lost, we say it's what it is, an oxidation process. So oxidation has taken place. So we write down the oxidation half equation. The iodide ion here becoming the iodate ion. So what we do, we are going to balance this equation. So to balance this equation, what we do, we are going to add water to the side that has more oxygen. So we add water to the side H2O. But by adding water here, what happened? We've introduced a new atom, which is hydrogen. But if you look at the subscript here, you have this to be what? 3. So we can place 3 in front of this. By placing 3 there, we now have what? 6 atoms of hydrogen and 6 atoms of oxygen. And to balance for hydrogen, we add hydroxyl ions. So we're going to add 6 hydroxyl ions on the side. So now you have the atoms to be balanced. Iodine 1, iodine 1. Oxygen 6, 3 here plus another 3, 6. Hydrogen 6, 3 by 2, 6. So we balance the charges. The charge we have is -1 and the charge is -1. But you multiply it by this gives us -6. So the total charge on this side will give us -7. And we look at the charge that we have on the side here. Just this one, that is -1. So the difference between -7 and -1, That is minus 7 minus into minus 1. So that will give us what? Minus 6. So meaning we are going to add 6 electrons to the side of the highest charge. This here is minus 7, here is minus 1. Minus 1 is greater than minus 7. So we're going to add 6 electrons to this side. So by adding 6 electrons here, the equation is now a balanced equation. So next we look at the reduction half equation. In the reduction half, we look at what? The tetrahexochromate 7. Chromate here from plus 7 into plus 3. There is a decrease in the oxidation number. And decrease in the number tells us electrons are gained. And if electrons are gained, that is reduction. So the tetrahexochromate ion here becoming the chromate ion. Here we have one atom of chromium, one atom of chromium. So the chromium atoms are balanced. We look for the oxygen atoms. Here we have 4 oxygen atoms and here no oxygen atom at all. So what we do, we add water to the side that has more oxygen. The subscript we're having here is what? 4. So we're going to place 4 in front of this. So by placing 4 there, we now have 8 hydrogen atoms. Okay? So in this case, to balance for hydrogen, we add hydroxyl ions. So we're going to add 8 hydroxyl ions. So by adding 8 hydroxyl ions, the entire equation is now balanced in terms of atoms. 1 chromium, 1 chromium. Oxygen 4 plus other 4, 8, hydrogen 8. Oxygen 8, hydrogen 8. So now we balance the charge. The charge we have here is negative 1. And the charge we have here is positive 3, and then we have negative 8, because minus 1 multiplied by 8. So this and this will give us total of negative 5. So the difference between minus 1 and minus 5, minus 1 and minus 5, you get minus 1 plus 5. So the difference is plus 4. So we add 4 electrons to the side of the highest charge. Minus 1 is higher than minus 5, so we add 4 electrons to this side. So by adding this, the entire equation becomes a balanced equation in terms of atoms and charges. So now that both the oxidation half and reduction half are balanced, so what we do, we ensure that the number of electrons lost and the number of electrons gained must match. So what we do, we've observed here that it is 6 electrons that are lost and here 4 electrons gained. So what we do, we multiply here by 4 and we multiply here by 6. So multiplying this by 4 and multiplying here by 6. But 4 and 6 are having a common factor, which is 2. 2 goes into this 2 times and 2 goes into here 3 times. So it's the same as we multiply here by 2 and we multiply here by 3. So 2 multiplied by this will give us 2I minus plus 12 hydroxyl ions to produce 2 iodate ions plus 6 molecules of water plus 12 moles of electrons. So that is for the oxidation half. We come to the reduction half. So we have 3 tetrahexochromate 7 ion plus 12 molecules of water plus 12 moles of electrons to give us 3 chromate ions plus 24 hydroxyl ions. So now what we do, we are going to add both equations together. We cancel the number of moles of electrons. And if you watch here, you have what? 12 hydroxyl ions. Here you have 24 hydroxyl ions. Okay? Here you have 12 molecules of water, and here you have 6 molecules of water. So what we do in this situation here, let's add both together first, then we do the subtraction. So here you find out that we have 2I minus plus 12 hydroxyl ions plus 3 tetrahexochromate 4 plus 12 molecules of water. This is on the reactant side. Now we look at the product side. We have 2 iodate ions plus 6 molecules of water plus 3 chromate ions. I'll extend it to this end. And then you have 24 hydroxyl ions. So now you have OH minus here, OH minus there. So what we do, we subtract here, say minus 12 OH, that's by the smallest. Here also minus 12 OH ions. Here we have 12 molecules of water, and on this side we have 6 molecules of water. So we subtract here by 6 molecules of water, here also by 6 molecules of water. So in this regard, plus 12 minus 12 will cancel, here plus 6 minus 6 will cancel. So we will be left with this. So what we now have will be 2 iodide ions plus 3 tetraoxochromate 7 plus 12 minus this 6 will give us 6 molecules of water to produce 2 iodate ions. 6 and 6 cancels, plus 3 chromate ions, and then 24 minus 12 gives us 12 hydroxyl ions. So this here is aqueous, this is aqueous, water is liquid, this is aqueous, this is aqueous, and this is aqueous. You can check to see if your equation is balanced. So how you do the checking is this. You check on the reactant side and you check on the product side. On the reactant side, you check for atoms and charges. On the product side, you check for atoms and charges. Okay, so checking for this, the atoms we have here, we have iodine, we have chromium, we have oxygen, and we have hydrogen. The iodine, we have 2. The chromium, we have 3. The oxygen, 3 by this 4 is 12, and plus 6 is 18. And the hydrogen we have is 12, because 6 by 2 is 12. So we also come to the product side. The atoms, we have iodine, we have chromium, we have oxygen, and we have hydrogen. Iodine, we have 2 iodine atoms. The chromium, we have 3. The oxygen, 2 by this 6 gives us, 2 by this 3 rather gives us 6, and plus this 12 gives us 18. The hydrogen, we have 12. So we find out that what the atoms are balanced. Now we look at the charges. The charge we have is -1. -1 by this gives us -2. And here -1 by this gives us -3. So -2, -3 gives us -5. So total charge on the reactant side is -5. And here we have a charge of what? -1 by this gives us -2. 3 by this 3 gives us +9. And this by this gives us -12. So -2, +9 gives us +7 and 12. So +7 minus 12 gives us -5. So our equation is a balanced equation because the atoms are balanced and the charges are balanced. You are not to write this in exams. You only work this out when you are practicing, okay? Because it is by doing this that you will know that your equation is a balanced equation or not a balanced equation. So next we look at the second example. Okay, now this is the second example. This example, we are going to look at it from 2 different perspectives, okay? How to use the concept of alkaline medium to balance it. Also, how you can use the concept of acidic medium and end up getting your answer in alkaline medium. So the answer to this, we are also going to assign oxidation numbers. Oxygen here -2, sulfur will give us +4 here. That's why we call this the trioxosulfate 4. Okay, call this the trioxosulfate 4. And here hydrogen is +1, oxygen -2. So +1 -2 gives us -1. So -1 by 3 here gives us what? A -3. If we transpose it over the equal to sign, it becomes what? A +3. So +3 -1 gives us here +2. So the nickel here has a charge of +3. Okay? And this nickel, no charge. Oxygen here -2, sulfur here +6. So that's how we call it the tetraoxosulfate 6 ion. So having assigned the oxidation numbers, we now look at the solution of 8. Now, we try to identify the species that have oxidized and the one that have reduced. So sulfur have increased in oxidation number. So that tells you it has oxidized. It is undergoing oxidation. So the oxidation half will be the sulfite ion becoming the sulfate ion. So what we do, we try to balance this. Sulfur here is 1, sulfur here 1, because the first thing we balance for atoms rather than oxygen or hydrogen. So sulfur is balanced. Oxygen here 3 and oxygen here 4. So what we do, we add water to this side. By adding water, we've introduced a new species, which is hydrogen. Okay, so to balance for hydrogen, what are we going to do? Now on this side, we have what? 4 plus this, 5. So we have 5 atoms of oxygen there. So what we do, we can add 2 hydroxyl ions. By adding 2 hydroxyl ions, sulfur is 1, sulfur 1, oxygen 3, plus this 2, 5. Hydrogen 2 here, okay? Sulfur here is 1, oxygen 4 plus this 1, 5, and hydrogen 2. So the equation is balanced in terms of atoms. Now we look at the charges. The charge on this side we have is -2. The charge we have is also -2. So -2 -2 gives us -4. And here we have a charge of what? -2. So the difference between this and this, minus this and this, gives us -2. So we add 2 electrons to the side of the highest charge. And the highest charge is -2 because -2 is higher than -4. So we're going to add 2 electrons to the side. We add 2 electrons here. So by adding 2 electrons to that side, the entire equation is now a balanced equation in terms of atoms and in terms of charges. We look at the reduction half. The reduction half equation here, we look at the nickel hydroxyl ion becoming nickel ion. So now what we do to this, here we have 3 hydroxyl ions. So what we do, we just add 3 hydroxyl ions to the side. So working this one out, the charge here is -1, the charge here is -3. The difference between -1 and -3 is +2 rather. So the difference between this and this is +2. Okay, so we are going to add 2 electrons to the side of the highest charge, and the one with the highest charge is -1 because -1 is higher than -3. So we are going to add 2 electrons to this side. So adding 2 electrons to the side, what happens then? We are now going to add both equations. So adding these 2 equations, 2 electrons are gained here, 2 electrons are lost. We cancel them out. So we have our equation to be the sulfite ion and 2 hydroxyl ions react with the nickel hydroxyl ion to produce the sulfate ion plus water plus nickel plus 3 hydroxyl ions. Now, if you look at this, you have hydroxyl ions here, you have hydroxyl ions here. So we can subtract here by 2 hydroxyl ions and here by 2 hydroxyl ions. So this cancels. Therefore, our final equation is trioxosulfate 4 aqueous reacts with nickel hydroxyl ion aqueous in an alkaline medium to produce tetraoxosulfate 6 plus nickel plus water and hydroxyl ion. So this is solid, this is liquid, and this is aqueous. So this becomes your balanced equation. You also check to see, you don't take things for granted. So here, say sulfur, we have 1 sulfur. Oxygen here 3 plus this 3 gives us 6. Nickel, we have 1 and hydrogen 3. Okay. We also come to the side. Sulfur here is 1 oxygen 4 plus this 5 and plus this 6, oxygen 6. And then we look at nickel and then hydrogen. Nickel is 1, hydrogen 3, hydrogen 2 here plus this 3. So we look at the charges. Here we have a charge of what? -1 and -2. So you have this to be -2, this -1, which gives you a total charge of -3. Here you have a charge of -2 and this -1, charge of -3. So atoms are balanced and charges are balanced. So this is how you can go about balancing this in an alkaline medium. Now, what if you have mastered the concept of acidic medium and you want to apply that idea here? That also can work out seamlessly. You get your correct answer. So let's look at that method. So here we are going to look at the acidic medium approach. So we identify the species that undergoes oxidation, that is the oxidized species. So here we saw that the sulfur increased. So what we do in this situation, to balance using the concept of acidic medium, we are going to add water to the side with less oxygen. So we're going to add water to this side, H2O. We know every molecule of water consists of 2 atoms of hydrogen and an atom of oxygen. So by adding this here, the oxygen atoms have increased to 4. But we've introduced a new atom, which is hydrogen. So what we do, we add 2 hydrogen ions here. So by doing this, what happens in this situation now? We discovered that the atoms are now balanced. Sulfur 1, oxygen 3 plus this 4 hydrogen 2, hydrogen 2. So what we do next is we balance the charges. Charge we're having here is -2. The charge we have here is -2 and +2. So -2 plus 2, they cancel, total charge there is 0. So we have -2 and we have 0. The difference between -2 and 0 is 2. So we add 2 electrons to the side with the highest charge. 0 is higher than -2. So we add 2 electrons here. So by doing this, our equation is now a balanced equation. So being that this is now a balanced equation, we look at the reduction half. So for the reduction half, we have the nickel hydroxyl ion becoming nickel here. So what we do, we try to balance for oxygen. We're going to add water. So we add water to this side. But by adding water, What happens here? The number of hydrogen atoms we have here is 3 and there is 2. Oxygen here is 3. So what we do, we place 3 in front of this. By placing 3, we've increased the hydrogen atoms to 6. The oxygen is now balanced. So what we do, we add 3 hydrogen ions to the side. So 1 nickel, oxygen 3, 3 hydrogen plus this 3, 6, 3 by 2, 6. So atoms are balanced. Now we balance the charge. To balance the charge, what we have here is minus 1, and what we have here is plus 3. And here no charge of 0. So this here gives us plus 2. So difference between 2 and 0 is 2. So we add 2 electrons. We add 2 electrons to the side with the highest charge. So we're going to add 2 electrons here. So by adding this, the atoms are balanced and the charges are balanced. So what we do next, we add both equations together. And by adding them, we cancel common stuff. 2 electrons here cancel. So in this situation, what happens here, we say the sulfide ion plus water plus the nickel hydroxyl ion plus 3 hydrogen ions to produce the sulfate ion plus 2 hydrogen ions plus the nickel atom and 3 molecules of water. But we have to balance this in what? In an alkaline medium. We're having here 3 hydrogen ions and here 2 hydrogen ions. What we do, we subtract here by 2 hydrogen ions and here 2 hydrogen ions. We have water here, We subtract here by a water molecule and here by a water molecule. So this cancels and this cancels. So canceling them, we are left with we have the sulfide ion plus the nickel hydroxyl. So 3 minus 2 gives us 1. We have the hydrogen ions this produced. Here we have the sulfate ion, okay, plus nickel ion plus this here gives us 2 molecules of water. But our target is to balance it in an alkaline medium, and we have seen hydrogen ion here. So what we do? We add hydroxyl to this side, and here also we add hydroxyl. So if this and this react, they give us water. So we have SO3 2 minus plus nickel hydroxyl ion plus hydrogen ion, and the hydroxyl ion will give us a molecule of water to produce the sulfate ion plus nickel ion plus 2 molecules of water and the hydroxyl ion. So it is now in an alkaline medium, but it's not yet finished. We have water here, So what we do, we subtract here by a molecule of water, also by a molecule of water, so this cancels. Our final equation, therefore, is sulfide ion aqueous react with nickel hydroxyl ion aqueous to produce sulfate ion aqueous plus nickel solid. 2 minus 1 gives us 1. There's water molecule liquid and the hydroxyl ion aqueous. So this becomes your balanced equation. So you see, you can also use the concept of acidic medium, and then you add just few steps to get your answer in an alkaline medium. Of course, thank you very much for watching our video. You can like our video, subscribe to the channel if you are new. You can as well follow us on TikTok. I have a TikTok account, Jalo Science Academy. You can follow us on Facebook, Jalo Science Academy, or you can send a message to the number popping on the screen there on Telegram so that we can add it to our Telegram group. We'll be sending your questions, your assignments, and we'll help you solve them. Thank you very much for watching this video. Assalamu alaikum and Ramadan Mubarak to all Muslims.